the energy required to break 1 mole of Cl bonds in Cl2 is 242 kilojoule per mole. The longest wavelength of light capable of breaking a single Cl-Cl bond is, right? It means the energy, how we will solve, how we will proceed. It means that the energy of light should be equal to the energy required to break 1 Cl-Cl bond. Right? Now, we are provided with the energy required to break 1 mole of Cl-Cl bond. So what we need to find out, what is required is the longest wavelength of light capable of breaking single Cl-Cl bond. So we are provided with 1 mole. So how can we find out the energy required to break single Cl-Cl bond, right? That is 1 Cl-Cl bond will be equal to what? The energy required to break 1 mole, that is 242, and how many bonds will be there in 1 mole? That is 6.023 into 10 to the power 23 joules, right? So I think this is in, it is given in kilojoules. I'll convert it into joules. So this is multiplied by 10 to the power 3 joules. Right? Now this energy is equal to the energy of the light. So 242 into 10 to the power 3 divided by 6.023 into 10 to the power 23, that is equal to what? The energy of light, that is hc by lambda. Now we know h here. H is what? 6.621 into 10 to the power minus 34. Right? And what is c? C is the velocity of light, that is 3 into 10 to the power 8. Right? So, your lambda, here, your lambda is equal to 6.626 into 10 to the power minus 34 into the velocity of light, that is 3 into 10 to the power 8 meter per second, and that is divided by what? Divided by lambda is equal to, divided by 242 into 10 to the power 3, right? And here it would be 6.023 into 10 to the power 23, right? So this calculation will give you the lambda. That is your lambda. Let's take out approximately. This will be 3 multiplied by 6. This will be 18 approximately, right? Then 18/6 is how much? It's 108, and that is divided by 242. So this will come out to be some 4, right? That is 18/6 is 108, right? I'm just finding out the approximate answer. So it is 108 divided by 242. So this will, if I'll round off this, I'll get 25. So 25 fours is 100, right? So approximately I'll get 4 as the first figure. Now let's find out where there is 4. This is 494 nanometer. right? So this is the way you can, just by rounding it off, and you can do the rough calculation. Students, here what you require is, you can't use calci, right? When you can't use calculator, so you need to do the rounding of things and all these things. So within a minute you can just calculate, and when you are provided with the 4 options also. So got it how we did? I think it's an easiest method. 6 multiplied by 3 is 18, multiplied by 6 is 108, divided by 242. 108, you can round off 108 to how much? 100. And 242, you can round it off to this as 25, right? 250. So this is 100 divided by 250, and this comes out 4. 4 is your first digit, right? And you can do your calculations either if you want. So the answer here is 4947,494 nanometers.